Hello. Today we're going to talk about how to use Go as a scripting language. When I talk to other people about this subject, they usually ask why, but I hope because this is a dotGo conference, I don't have to convince you, but in case there are some heretics here in the hall, here are some points to digest. So we know that Go is easy to learn, write, and read. It's a huge ecosystem of already ready code. You can just go get what you want. It's compiled and strongly in type. If you use it as a script, other interpreted languages, basically, when they run half of the script, then there is a typo, and your system is broken and inconsistent state. Hopefully, Go will fix that. And it's low-level enough for the different system tasks. What I particularly like, it's like more than easy integration with C code. Some potential use cases. Let's imagine a Go build system for your Go projects. Why you use Python if you like Go, right? Quick Go code prototyping and easier script templating. Sometimes you want your code to be in the source form to stack it into config management systems or something like that. And well, basically anywhere where Python is used now, you can replace it with Go easily. So, okay, how do we do that? So what do we need as an environment for a proper script? We need an operating system, we need a programming language, and an interpreter, right? So for an operating system, for the purposes of this talk and the greater good, we will use Linux, because it's the only real operating system. Programming language is obviously Go. And what about the interpreter? Like we say, how do you run your Go code in source form? And people will say, oh, there is this official tool Go run, and maybe we can use that. So can we? Let's take a simple Go script as an example. It's a plain hello world program. And let's try to run it as a script. We go run, and you see the output. By the way, although these are slides, these all have been copy-pasted from a real terminal, so don't worry, it's like a demo. So yeah, you can run your Go script, right? But we need more, right? From a script, we need script to be able to parse command line arguments. We also need the scripts to return proper error code to the operating system, because oftentimes you change the scripts in a complex pipeline, and return codes is the way how they interact with each other and with the operating system. And also, you don't want to be typing Go run every time you run your Go script. You want just set the executable bit and execute it as a regular file. So how do you do that? Let's check if we can have an example of a script with our properties. So our script will be slightly modified. It accepts one command line argument, and on a specific condition, it may fail with the exits with the return code. Sorry, don't ask me what sorry is. I don't remember. And finally, how to achieve the executable part? In Linux and most Unix-like operating system, you do it with a shebang line. So the shebang line is just the first line in your script. It starts with a hash, exclamation mark, and the pass to the interpreter. What shebang line does, it tells your operating system. And keep in mind that it tells your operating system, not your shell, which interpreter to use for the script. And I will come back to that later. OK, let's add a shebang line to our toy script. Here it is. We just add go run. Let's check if it works. If you try to execute this file, it will fail. Why? Because unlike many other languages, a hash is not a valid comment in Go. And people have been asking for this feature. Can we make an exception just for the shebang line? And Go maintainers said no for some reason. I don't know why. I mean, there is a lengthy thread. You can Google it. So when somebody does not want to, official maintainers do not want to support feature, we go to the community, right? So, and people on Stack Overflow came up with a brilliant idea, let's just exploit the properties of specific shells. So most shells will try to execute your file as is, line by line, if you don't have a shebang line. And for file system paths in Unix, // is same as single //, but // is a valid command in Go. So they replace the shebang line with this is my term, I call it shellism line. just by replacing the hash with // and adding these magic things to make parameter passing work. OK, let's try to execute it now. But let's also check if the parameter passing works. So you will see something like that. So you see the expected output, but some garbage in the end as well. So what happened here is the script was executed, but the bad thing, and even the parameter passing worked, but the bad thing is like you also get some garbage appended in the end, because the shell executed the first line. It was the shellism line, as I call it, and then tried to execute the source file line by line itself, and you get all this garbage. So Stack Overflow people don't give up. Yeah, we can terminate the shell execution early by adding this exit to the shellism line. OK, let's check it. So yep, the parameter passing worked. Let's try the failure case now. So we tell the script to fail, and you will see the expected output, but you also see some weird line appended with an exit status 30. And when you check the real exit status, you will see it's 1. So what happened here is the script was executed, the parameter passing worked, and the shell terminated properly early. The bad thing is that Go run tool, for some reason, masks the real non-zero exit status of your script and always returns 1. And also, it appends your real exit status as an output to your line. Stack Overflow people don't give up. They say, yeah, like, I mean, I didn't even want to paste this here, because they say, like, we will add this weird, huge code which will consume the line, parse the real exit, like, and at this point, it's like, no, this is just too complex for it. Go should be simple, and Go scripting should be simple. And like, if you check with Python, it's like, it's simple, but that is too complex. And what else they failed to notice, and this is like my addition, let's say you have this Go script and you go to that weird Stack Overflow approach, you execute it from your shell, it will work. But if you try to execute it from another program, let's say Python or some other code, you will see an error. And why is that? To understand it, you need to understand some Linux internals, and this is an interview question, by the way, so keep attention. So if a new process wants to execute a script, it sends a so-called exec system call, which gets forwarded to the operating system kernel. Because there are different executable formats, the kernel has different modules which are responsible for parsing different executable formats. And when you execute a script, there is a bin format script module, which is exactly responsible for parsing a shebang line. So when you execute a script, actually the kernel passes the shebang line and not your shell. And that module knows how to launch your process. So shebang line processing happens inside the kernel. That's why it works from any shell and from any other process. Whereas the shellism line is processing happens inside the shell, so it doesn't work outside of the shell. OK, so what we know, that Go run is no good. We know that shellism approach is also not good. It's very complex, and it doesn't support all the use cases. So let's try the shebang approach one more. So because like the official Go run tool does not do what we want, so we have this additional, people came up with additional custom tool called Go run without the space, which does what we need. And so it's built to compensate the shortcomings of the Go run, and it consumes and, I don't know, ignores the shebang line. So it allows you to have a hash, and it returns proper exit status. So let's try the shebang line with the custom Go run tool here. OK, so parameter passing works. Let's try to fail the script. You get the output and check the real exit status. It's what we expect. Let's try to execute it from another process, and it will work as well. But finally, let's try to compile it. Like, I'm fed up with my script. I wanted to now compile it to a real program, and it will fail again. Because we made an exception for the Go run for the scripting part, but we didn't make an exception for the compiler. So it seems I can't have the perfect solution, right? I can't have Go scripts, which are valid Go programs and scripts at the same time. OK, let's go back to the basics now. How can Linux help us in this case? When I was looking through all the modules in Linux, I found this strange module called bin format misc, which basically means everything else. So maybe I could use that. And turns out I can. So bin format misc in Linux allows you to register custom interpreters for custom files and scripts. So it basically allows you to create your own executable formats. And you can nominate your executables either by a file, magic header, or an extension. And surprisingly, for a kernel feature, it has great documentation. So it's very easy to digest. The way how you interact with it, you interact with a special virtual file system. And you just tell it which files are to interpret and how to interpret them. So the simple example, first of all, you check if your bin format misc file system is mounted. It probably is for a modern system D distribution. And then you feed for this magic file, this magic weird, strange line registering. But what it basically says to the kernel, if you encounter an executable .go file, you should execute it via go run interpreter, like the custom go run interpreter. And the way how it works in action, so if a user process will try to execute Go file, this exec call will be forwarded to the bin format kernel module. That kernel module will actually see that it has a line registered for that specific format, and it executed via your nominated interpreter. So the real user process would look like that. OK, so let's try it. So a simple script with nothing. There is no shebang line, no shellism, no quirks. It's a plain Go program, assuming we did all the magic bin format misc stuff. So parameter passing worked. Failure case, no extra output here, and the exit status is as we expect. Let's try to build it now, and it builds just fine because it's a valid Go program with no stupid hashes. And let's try to execute it from another process. It will work fine as well, again, because all the processing happens inside the kernel, so you can execute this file from any environment. Yes. So now I'm satisfied. And yes, you can use Go as a scripting language. So some conclusions here. Go may be useful as a scripting language. Who still doesn't agree? Catch me later behind the corner. Unfortunately, standard Go run tool was not meant to be a true Go interpreter, and Go, because it doesn't accept any hashes, it can't make any exceptions. Yeah, as I said, Go run was not intended to be as a proper interpreter. When you ask Go maintainer, so why is that invented then? What is its purpose? So nobody can really tell. I mean, if you know, please text me. I would really be interested. And bin format misc is a very neat Linux feature which can allows you to turn Go into a true scripting language. If you were attentive enough, you would probably also notice that the approach is generic enough, so you can just throw away Go here and turn like any favorite language as a scripting language. You can script in Rust, C, and like Java or whatever. So it's like a huge inclusive ecosystem of scripting languages. Here is some useful links. I will share them later, so no need to take pictures if you want more information. And don't take my word for it. Here are some happy customers of using bin format misc module and Go scripting. Some of them are going to present later, so you can verify my statement here. So, yeah, thank you.